Thank you everyone for joining. Today we have Ceramic with us. Joining us today, specifically Joel Thorstensson, great, who will be presenting a workshop on primitives for dynamic data on Web3. Thank you so much. I will let you take this over in a second. Everybody, if you have questions, please feel free to put them in the chat. And Joel will get to them as he goes on with his presentation. I'll hand it to you now.
All right, thanks, Catherine. Let me share my screen and then get started. All right, so kind of just going to start with a few slides to give you guys an idea of what Ceramic is. So I think the screen should be showing now, so let me know if not. So yeah, Ceramic. So Ceramic is a protocol we've been working on for a while. It came out of some insights we had while working on a previous project called 3box. And really what Ceramic is like provides really kind of lower level primitive for having mutable data on Web3 without having to put like all the things on the blockchain. So yeah, it's basically mutable data on Web3. And how does that work? So in Ceramic, an object is also a stream, and basically a stream is a bunch of events that are linked together, and then there's a processing on top of the events, and then you get like a state, and that's like the current state of the object. And you can, yeah, so I kind of mentioned, you can view this as like a minimal building block for data that mutates over time. And these streams have a stream ID, and they act as persistent identifiers. And that means basically that you can always use the same stream ID to fetch the content of the current state of the stream, and you will always get the latest state. And so Ceramic is a global environment for mutable data. So I can run a node on my machine and then load some stream from someone else's machine. And one of the main differences between this and blockchain is that I can trustlessly verify just one stream. I don't need to like verify an entire blockchain worth of data. So this makes it kind of very decentralized and scalable. And so underneath the hood, this is using IPFS for like pieces of content, and Ethereum to like anchor and get like an audit trail of updates. And yeah, so commits, the events in the streams are originated locally. It's signed by the user, and the streams themselves are made of an append-only log, and a few different kind of stream types are supported. So stream type basically defines the update logic and conflict resolution strategy. So like if there is a conflict in this append-only stream of events, like how do we resolve the conflict? And it's a DAG data structure. And so that might be like one append-only log. It might be in the future we wanted to support like forking and merging back again. But yeah, that's kind of a general overview of like the primitive. So I'll jump in a little bit into kind of how it works. And then soon we'll kind of jump in and get started with playing around with the CLI. So commit streams we talked about. To the right, you can see how it kind of the data structure kind of looks like. So you have Genesis commit, which contains the first update you make or the creation event, and then it can be anchored into a blockchain. And then basically, right now, Ceramic has the concept of an anchor service, which takes a bunch of different streams, bashes them into a big Merkle tree, and puts the root of the Merkle tree on chain. So we can minimize the amount of transactions we need to make on chain. And then basically, like we have these signature commits, so that they include like a patch to the state. And so you can imagine the state is like a JSON object that mutates over time, and the signature commits contains the patches to the object. And yeah, and then the stream kind of progresses like this as the user makes updates. And the nice thing is I can process each stream independently. So and I kind of mentioned this earlier, you can sync an individual stream. Right, you already talked about stream processor stream types, and then shake pointings. Yeah, I mentioned this as well. Periodically, it's anchored into the blockchain, And one of the reasons for this is it gives us kind of a proof of publication that this commit, like the signature commit, for example, existed at a certain point in time, and there's no way someone could, fake that. All right, so I'm going to talk a little bit about using Ceramic. So if you can use Ceramic protocol directly, and that allows us to get kind of to create, read, and write streams, and it allows us to have full control over the data flow. So if you want to really control how your application works and how it interacts with these kind of lower level data objects, you should be using Ceramic directly. We also have a kind of protocol on top of Ceramic, which is called IDX, which you can think of as kind of like a decentralized user table, where you can store data, and the data is stored with the user. So the user kind of gets full control over the data. That every change that's made is actually signed by the user. And the nice thing about IDX is you can kind of semantically define the data sets that is associated with the user. So they have to like include a JSON schema, which exactly describes the kind of data that's expected there. And generally, IDX is the best place to store user-generated content. And we also provide something called 380 Connect, which is an interface so in Ceramic, we use something called DIDs, which is decentralized identifiers. I'm not going to go deep into that now, but it's basically a way to interact with a user identity and request signatures and requests things to be decrypted and stuff like that. So 380 Connect allows any blockchain wallet really to authenticate and start reading and writing data on Ceramic. And 380 Connect also allows you to like tie an Ethereum address to your DID, so you can look up data based on like an Ethereum address, but you could also like tie that to like other blockchain addresses, like Filecoin or Cosmos or Polkadot or what have you. So it kind of really enables the data that the users have to be interoperable across the Web3 ecosystem. Yeah, so that was kind of a short presentation. If you want to jump into like looking at the documentation, we have that at developers.ceramic.network. And if you want to learn more about IDX, you can just go to idx.xyz. And so before I kind of jump into the workshop itself and looking at how to use Ceramic directly, I would love to like answer if there's any questions on what you just heard.
Hi, Joel, it's Case. I have a question. Hey, I have a question about the anchor commit. So actually about the Genesis records. So in IPFS, if I would publish an item, like let's say I use schema.org and I say company and I say 3box labs, and I'd be the first to do that. You know, in IPFS, it doesn't really matter because that content is just going to determine the hash and hence the address. In Ceramic, if I would do this same content twice, I'm guessing the Genesis block would look different because I'm using a different DID, I'm using a different timestamp. But what if I wanted to sort of search all the documents that have schema.org company 3box labs in it, in the content? Is there some sort of indexing that we could use for that?
Yeah, that's a really good question. So right now, you could build an indexing service that listens to the gossip that happens in the Ceramic network and see like, oh, this is a stream I don't know about, and then load that, check if it conforms to like a specific, or it has like a specific schema. But obviously, like that might be pretty expensive, and it's also like subjective to like the node that listens to like the gossip in the network. We are working with the graph to natively index Ceramic, and basically it will look at the anchor commits, and the anchor services can include like a Bloom filter that says like, oh, there was a stream with this specific schema that was included in this anchor batch. And so then an indexing service like the graph could look at that information and find the relevant streams and make an index based on that.
I have a question.
Thanks.
So the data, is that stored on, I'm guessing it's the nodes running on the Ceramic network. So like on IPFS, you have to pin files. Is there some sort of a pinning mechanism or like some for long-term ensuring that the data is always sort of accessible? What's the solution to that?
Yeah, so right now if you run a Ceramic node, you can pin streams. And what that means basically is that the Ceramic node will, the commits themselves, they'll pin that, the Ceramic node uses an IPFS node underneath. So we'll pin the commits on the underlying IPFS node, but the Ceramic node will also keep track of any new update that comes in for that stream, and keep track of what the latest state is for that stream. So we have, for kind of the persistence of the commits themselves, like the IPFS objects, we have a backend to like make deals with Filecoin to back those up. And then and they could also be like, that's modular, so that could also be like plugged into an external IPFS node that's run by a third-party service, or it could potentially be plugged into something like Arweave. So we really want that commit persistence to be very flexible in terms of like which decentralized storage solution you want to use, because Arweave has like different properties than Filecoin. And then in terms of keeping track of the latest state and the latest updates to a stream, right now you actually need to run a Ceramic node and have at least one Ceramic node that keeps track of that. In the future, we will be working on adding an incentive system that you can basically pay to keep track of your streams for you. So then that would look like some set of validators that basically work on tracking the pinned streams that have been paid for. Yeah, I hope that answered your question.
Yes, it does. Thank you.
Cool. So let me jump into the example that I wanted to show. Oh, shit, I stopped sharing. Give me 1 second. All right. So what I'm going to be doing is basically just using the Ceramic CLI to get you like an idea of like how you can start using these primitives and like how to think about them. So the first thing we want to do is create a Ceramic daemon. And what this does is basically it will start Ceramic on the testnet, and it will in the background spin up an IPFS node and connect to an Ethereum node. I think by default it connects to Infura, if I'm not mistaken. But if you don't pass a configuration, you might run into rate limiting. So you can pass like IPFS API, you can pass like Ethereum configs. So like yeah, there's a bunch of configs you can pass to the Ceramic daemon, like Ethereum RPC or other things. But yeah, right now we're just gonna kind of run the vanilla. So yeah, this just starts the Ceramic. See, it listens on IPFS and has some config, and it connects to the Ceramic network and then starts the Ceramic API. All right, so then next, what we want to do, let me clear up here a little bit, is so we can use the Ceramic CLI to create a tile, and I prepared here. So here we're just going to create a stream in Ceramic, which is called tile. So tile is basically is the JSON object or JSON document on Ceramic. So we can create this, and as you kind of expect, it just like gives you back the content which you used, and then you'll get a stream ID, which is the kind of permanent identifier. So if we do Ceramic show and this stream ID, we will again see the content. And we can also update the stream. So let's do that. So I'm just going to copy this and add some more stuff here. So description. All right. And we make an update. So now you can see the new state. So obviously this is just the pure kind of content of the document. We can also look into the kind of underlying state of the ceramic stream. So we can do ceramic state, and then, okay, that's not right. Copy the stream ID again. And now we can look at the state. So here, there's a bunch of stuff, but here we can see the document type, which is a tile, but in kind of a binary representation. And yeah, so here we see the whole kind of state. So there's a bunch of stuff in here. Content is the content of the genesis right now. There's some metadata, and in here we see which DAD is being used. So by default, the ceramic CLI provides the keydid, which is basically just the public-private key pair. And unique allows, basically when you create a tile in ceramic, it will automatically add some randomness to that. So you can create the same content multiple times and get different stream IDs. There's, which in most use cases you want. In some cases you might want to create the same, and there's options for that, but I'm not going to go into it right now. Then we can see that it has been signed. There's like a signature status. And now we can also see that we have an anchor status that's pending. And that basically means that our node, or like our ceramic, local ceramic node that we have started, has made a request to an external anchor service that will eventually anchor this commit. And here we see a log. So here we have type 0, that's the Genesis commit. Here we have type 1, that's a signed commit or signature commit. And so yeah, the log is basically all of the updates that we've seen. And yeah, so then we see here also when the anchor is scheduled for. And yeah, so one thing to note here is next contains kind of the state that we updated to. And once the anchor is kind of executed, then this kind of next state will be finalized and will become part of like the main content up here. But if you just do like ceramic show right now, we're kind of, that's annoying, ceramic show, it will just kind of grab the latest kind of pending content here. Right, so let's see, this is actually scheduled for, oh, that's too late. But yeah, I think this anchor service runs like once every 15 minutes, so we might not be able to observe an anchor. Cool, so I see there's some question in the chat. So is the signature done by an external node or the one running locally? So it's done by the local node. And so right now, so the CLI here, we have the daemon, and then we have like the command that executes. And in the background, this is just running an HTTP client. And yeah, so the keys live locally with the client. So if I'm actually now going to show you, actually, let me show another thing on the CLI. So I can also do list the commits here. So I'm going to type ceramic commits, and we copy the stream ID. And now we can see that there are two different commits here. One is the Genesis commit. One is the commit ID of the kind of first signed update. So we can actually now do ceramic show and the Genesis commit. And then we will see what the state was before. See, there's another question in the chat. Will it cost any ETH to anchor the stream? So practically, I mean, it depends. So like generally there is a, you usually configure your node to work with an external anchor service. And this anchor service basically takes a bunch of updates from a bunch of different streams and makes one transaction on-chain. So it's the anchor service that makes kind of the on-chain transaction and pays ETH. So on the testnet, you can use that kind of for free because it's on Ropsten. On the mainnet, you might need to like engage with some service provider that does the anchoring for you, and then maybe you pay ETH to them, maybe you pay, you know, by some contract, so some kind of fiat, but it's really kind of up to the application developers to set up that agreement, or like, yeah. So the next question I see, which makes sense, is there any decentralization on the Anchor service itself? So right now there isn't, but anyone could run an Anchor service. So there's no like centralization on any one particular Anchor service. But I mentioned earlier when I was going through the slides that we are working on like an incentivized system for keeping track of the state. And that will actually decentralize the Anchor service as well. So that's planned. But yeah, there's no like lock-in into like a particular Anchor service. So if one Anchor service would be censoring you, for example, you could just engage with another provider. All right, so now I'm just actually, let's see. I'm gonna change directory here. So now I'm actually gonna show you the HTTP client that you can use in JavaScript. So the first thing we're going to do is require and just import the Ceramic network / HTTP client, which is an npm package that you can find on npm. So we're just going to load that. Then we're going to do let ceramic equals new ceramic, and we're just going to point this to our local node that we had here. All right. So what we want to do now is basically just like load the document. So load doc equals, or let doc equals ceramic dot load stream, and we're just going to pass the stream ID we created over here. Oh, I did not do this in the right way, because we need, this returns a promise, so I need to wait. I'm gonna call it tile. So do tile dot, we can just do content. Now we see kind of the same content that we saw before. And we can also do like tile dot metadata dot controllers, and we'll see like, oh, this is the owner of the data stream. And so now we could like make, basically we can just show that we can observe kind of updates here. So we can do tile dot, wait, so actually let's go back to here and let's make another update and just add some word here. All right, so you can see we have made an update. So I think if we just do kind of content here again, we'll see the old content. This is because we haven't, by default, we don't subscribe to updates. So I think we can do tile.sync and await this. And we should be able to look at the content. And yeah, we can see the updated content. I think if I remember the API correctly, we can do subscribe here. And I think, so this returns a kind of observable. But I wonder if we just do that, we might get the content for free. Let's try. Okay, now I can see. Okay, yeah, so that I misunderstood here. So basically you need to consume this observable to get like a stream of updates that comes to the tile. So like now, I guess if we sync again, we'll get the content here. All right, so I think we have 5 minutes left. So I would love to answer like questions if any questions came up, or if there's something specific people are wondering about. All right, if not, I can actually try to show like a last thing. But Catherine, anything else you wanted to like? Okay, so there's a good question in the chat actually. Do you have support for JSON LD or Seaboard LD? So there's some native support. One thing that you can do, however, is just like put JSON LD content inside of a tile document in Ceramic. And that basically is you include the context, and that's basically it, right? You then have JSON LD inside of a Ceramic document. And another thing that Ceramic supports, which I think is too little time to demonstrate here, but you can actually create a JSON schema. So JSON schema is basically some JSON data that defines like a schema for other JSON data. So you can create one of these tiles that is a schema. And then when you create a tile, you can do like, you can you can specify the content, but you can also specify schema. And the schema can be a stream ID as well. So if you created a schema first and then create a new stream, you can reference the schema stream in your new stream, and then Ceramic will automatically enforce that the JSON content in the schema conform, or in the stream conforms to that schema. So that will kind of give you more guarantees around kind of what the data you can expect from when you load a stream. This is also something that's used in IDX to kind of more semantically describe data that you can expect when you're requesting data from users. All right, any other last questions, I guess, before we close?
Anything else coming up? Well, I will invite everyone who has any remaining question to simply go to the Discord and connect with the Ceramic team on Discord. This is really the best place to get in touch with them and ask your questions as you hack along during the next few days. So thank you so much, Joel, for your presentation and for all the answers to the questions. I think that was super informative for everyone.
Cool, yeah, thanks everyone for joining.
Great. Have a great day.